Hello, this is Calu student meteorologist Nathan Martin bringing the first in a series known as What in the Wide World of Weather on a topic that's both mesmerizing and dangerous at the same time. Lightning.
So, what in the wide world of weather is lightning? In a basic sense, it's static electricity.
Yep, that's right. The same thing that happens when you rub your sock against carpet for a while and then touch anything metal. Ow! It's almost exactly what happens in a thunderstorm to produce lightning. The only difference being the amount of electricity that is being generated and what is being rubbed together.
See, as a thunderstorm develops, it slowly rises through the first layer of the atmosphere called the troposphere, the layer where all weather occurs. Soon, this rising cloud reaches a point where it cannot rise anymore and flattens out into a classic anvil shape that has been seen in many photos of storms taken from a fair distance away. Precipitation forms within this towering cumulonimbus cloud, with a well-developed storm typically having very small ice crystals in the upper levels of the cloud, a mixture of the small ice crystals and hail in the mid-levels, and the lower levels typically having a mixture of rain with melting hail. Also within the storm are rising and falling air currents that bring moisture and, in this case, precipitation, higher and lower in the cloud, known as updrafts and downdrafts respectively. Finally, this is when lightning starts to form. As all this precipitation moves within the cloud, it crashes, bounces, and rubs against each other, building charge and causing the ice crystals in the upper levels of the cloud to become positively charged, the small mid-level hail to become negatively charged, and the base of the cloud becomes positively charged, along with the ground directly beneath it. The ground around the cloud becomes negatively charged. The air acts as an insulator, preventing the charge in the cloud from being released. But with so many small particles constantly interacting with each other within a massive area, the charge buildup becomes too great for air to contain, and the rapid discharge of electrical energy we know as lightning finally shows itself. Now, when lightning strikes, it is then broken down into two self-explanatory types: intracloud lightning and cloud-to-ground lightning. Intracloud lightning is what happens when lightning strikes within a cloud. Cloud-to-ground lightning is what happens when lightning strikes from a cloud to a ground. Fairly simple. Now, when lightning strikes, it superheats the air to nearly 50,000 degrees Fahrenheit. That is nearly 5 times hotter than the surface of the sun. The superheated air expands rapidly, producing the rumbling and deafening close sound waves we know as thunder.
Now, typically, you can hear thunder that is about 10 miles away from the strike itself. Even then, you are still within striking distance of lightning, as lightning can strike 10 miles away from its origin point. That is why the National Weather Service has the cheesy yet very important slogan of, "When thunder roars, go indoors." Now it's like, where should you seek shelter when there's a storm nearby and you're outside with no other buildings around? Should you A, get in a picnic shelter, or B, get in a car? If you chose B, congratulations, you live. If you chose A, well, I'm sorry. You might have been just electrocuted by lightning. But why? Well,
Ground currents. Even though the ground beneath is a very poor conductor of electricity, the sheer amount of electricity that is being discharged into the ground radiates out from its contact point and can travel through the ground and through the concrete to you and electrocuting you. And these tendrils can be seen thanks to a post by the National Weather Service on its Twitter page.
but what about the car, some might say? Isn't that made of metal? Wouldn't that be worse than a picnic shelter?
The answer to that is no. While there is metal surrounding the car, there's typically no metal inside the car where you are sitting. So the electricity will travel through the frame of the car and exit through the tires. But even then, please keep away from any metal inside the car.
Lightning fast facts.
A single bolt of lightning can be charged with up to 1 billion volts of electricity and can dissipate nearly 300 gigajoules of energy. That's enough energy to power a 100-watt light bulb for 95 years. Lightning can and will strike the same place twice. Just look at the spire on top of the Empire State Building. Worldwide, lightning usually strikes the Earth's surface nearly 100 times per second. The longest recorded lightning strike from its origin point was recently confirmed by the World Meteorological Organization to be a staggering 199.5 miles long in Oklahoma on June 20th, 2007. The longest lightning flash duration of 7.74 seconds was recently recorded over, pardon my French for this, Provence-Alpes Côte d'Azur?
Provence-Alpes Côte d'Azur.
This place in France.
And that does it for this first installment of What in the Wide World of Weather Is. Join me next time as I take a look at tornadoes. And remember, the more you know about weather, the better prepared you can be when it strikes.